All right, let's run another quick one down. Let's just run through some polar coordinates examples from 7.3. The main idea, right, is our sort of usual coordinate system, the xy coordinates. These are called rectangular coordinates, right? X is sort of left and right, the y value is an up and a down. Polar coordinates have a radius and an angle. And so this is going to call back to all of our trig stuff, right? So our radius is just our distance from the center. And our angle, right, is our just angle of rotation in standard position. So, like, for instance, if I was trying to just graph a few polar points, so if I was trying to graph something like 3, 45 degrees, right? Let's say this is point A. So what I need is a little bit of a polar axis. Now, instead of marking this sort of like a checkerboard, what we're going to do is we're actually going to mark, I'm going to use just dotted circles to try not to smoosh this up too much. We're going to get a little bit of a bullseye going, where what I'm sort of making is a little circle for each radius. So this is kind of radius 1, 2, 3. I'll put maybe one more on here. Something like that. And so if I'm going to graph a point like 345 degrees, so this is out to radius 3, and then you're rotating 45 degrees. So that's our first quadrant. So point A is here, right? So we're kind of 45 degrees out, right? And our point is there. So in theory, we're sort of describing the same kind of position we could describe with an xy coordinate. We're just getting there in a little bit of a different way. So it's just a little bit of a different system to sort of describe points. If we do a couple just quick examples, right? You could do radian type stuff, right? Let's say our radius is 2. Our angle is like, I don't know, 7 pi over 6 or something, right? So that's like a quadrant 3 angle. So that's going to rotate right down to here. This is sort of 30 degrees past 180. And then radius is 2, so out 1, 2. And so our value B would be there. Get a little tricky with this. You could do something like a negative radius. Let's do sort of radius is negative 2, and the angle is like, I don't know, 150 degrees. So what that means now is you're going out to 150, you're rotating out to 150, so you're sort of facing 150, which is out into quadrant 2. If your radius is negative, however, right, you're sort of facing this direction, but the way you're going to move is you're actually going to move backwards 2. So you're going to go back 1, 2. So you're sort of facing quadrant 2, but you move backwards into quadrant 4. So you're kind of moving along what would be essentially kind of 1 pi more rotation. This would be kind of 180 degrees past this. So if 150 is here, you're going plus 180, you're really kind of moving along the 330 line. Last but not least, right, if you wanted to do something like a negative rotation, I guess that's fine also, right? Let's go all the way out to 4, but we could do a rotation like negative 3 pi over 2. So that's going to be, okay, so negative 3 pi over 2, that's like a negative 270. So you're rotating backwards, sort of 90, 180, 270, right? 1/2 pi, 2/2 pi, 3/2 pi. And then out, 1, 2, 3, 4. So we'll mark our value up there. That's our value D. If we wanted to connect these polar coordinates a little bit more to the rectangular coordinate system that we're more familiar with, what we're going to do is we have, so to connect x's and y's to our radiuses and our angles, what we have essentially, right, if this is my point, I'm going to have, right, x value is here, y value is here, and then from a polar perspective, I could fill in my radius up here, and then my angle is going to be there. I've essentially just recreated my right triangle picture from 5.3 or whichever section it was. I think it was 5.3. So all those relationships are still going to hold up. So that means that like I have a Pythagorean theorem type relationship, x squared plus y squared would be r squared. I would end up with some SOHCAHTOA type relationships, right? So like the sine of the angle would be like the y value divided by the radius, and then what we're going to do here is actually cross multiply, which means the y value would be the radius times the sine of the angle. So we're going to use that. Cosine of theta would be the x value divided by the radius, which means the x coordinate itself would be the radius times cosine. So these two give me a way to sort of go from a radius and an angle to an x and a y. We could do tangent of theta, and so tangent only involves the y and the x. So in some sense that gets us a little bit of a thing where we could say the angle would sort of be a version of the tangent inverse of y over x. It's not perfect, right? You'd have to sort of mind the quadrant here, right? So it's not going to sort of perfectly follow our sort of quadrant angle type values. We just sort of give you a quick example of sort of converting between each of these two forms. So for example, if we convert, so let's say, right, 5 and then like 120 degrees, let's convert it into rectangular. So all we're going to do is say, right, so this is my radius, this is my angle. So the idea here is the x value should be 5 times cosine at 120 degrees. What the heck is cosine at 120? Negative 1/2. So this would be like negative 5 over 2. The y value here would be 5 times the sine at 120 degrees. So this would be like root 3 over 2, so it's going to be 5 root 3 over 2. So then the like xy version of this is going to be negative 5/2 and then positive 5 root 3 over 2. If I wanted to sort of reverse this relationship and sort of run an example going the other direction, so if I wanted to do something like convert, what's a semi-decent point? I don't know. Something like 6 comma negative 6 into polar. So what we would do now is you would say, okay, so this is my x and my y. I need to find the radius and I need to find the angle. The radius is a little bit more simple, right? The radius should just be Pythagorean style. So this means, right, r squared is going to be 6 squared plus negative 6 squared. 36 and 36. So that's 72. Long story short, we simplify this. That means my radius would be root 72, which would look like 6 times root of 2. Radius is always positive, right? So we're not going to play around with is it plus or is it minus. For the angle, a little bit trickier. So tangent of the angle should be y over x. So that's negative 6 over 6. We need to note a little bit which quadrant we're in, right? Positive x and negative y. That's quad 4. Negative 6 over 6 would be 1. So I need tangent of theta to be negative 1 in quadrant 4. Where's that going to happen if we do a little unit circle arithmetic, right? The tangent values aren't on there directly, but we can get to them with a little division. That's going to happen for us at 315 degrees or 7 pi over 4. So our angle here would be 315 degrees. So then our polar value, sneak this in right here at the bottom. So this is going to look like 6 root 2, and then the angle is 315. So that's the basics of it, right? Moving between these two forms. That's the idea.